This is a direct quote from your book. Don't freak out. I'm going to try to clarify it, and if you don't understand after I clarify it, then it might be time to start freaking out. But this is what your book says. We're still talking about stretches, but we're going in the opposite direction. We're going in the x direction. A graph of y is equal to f times a of x, or when a of x is in a function. No, I'm going to hopefully clarify this, is a stretch of y is equal to f of x, with the stretch factor 1 over a parallel to the x-axis. So what we're looking at is a stretch going, it says parallel to the x-axis. So this is the x-axis, so it's going to stretch this way instead. We're going to talk about this later. I know that's confusing. Please put it on hold for a little while. Alright, so we're going to use the same equation for this, same as the last example. Remember, we're stretching it this way. And I went ahead and drew the original equation. Okay. What if we wanted to find out what happens with this parabola, how it stretches if we put 2x in there? Now, why someone would want to do that is beyond me, but we need to find out. So we have to discover this because we have a test that we have to prepare for. So notice that I substituted the 2x in for the x here. And this, notice also we still have the 1. So that's going to shift our parabola up to 1, up on the y-axis to 1 here. But it's going to be altered a little bit. And now I want to talk about the scale factor. So we're going to focus on this part, the 1 over a. So ask yourself right now, is it going to get wider or is it going to get narrower? Okay, and I went ahead and drew the ordered pair. Anyway, so 0, 1, this is our original function. So here we are at 0, 1, and then 1, 2, negative 1, 1, and so forth. So we've already seen this parabola in the last video. But now we have a stretch. So we put 2x in for x of our original equation. And that's what this is asking us to do. That's what this means. It means put this in for x of the entire equation. Now, when we're going to deal with cubics, you put it in 2x, to the third power, then to the second power, then you don't have to put it in for the constant. But if you notice, our vertex is at the same place. So it's at 0, 1. And that's the point I'm trying to make, is this part. The stretch is going to be a factor of 1 over a. We multiplied it by 2. So the stretch is going to be of a scale factor, stretch factor as they call it, of 1/2. So we're going to go to 0, 1. The vertex is at the same place. And then we go to 1, 5. So we're going to get a parabola like this. I'm going to show you in Desmos in a moment. And it's going to be thinner, but the vertex will be at the same place. So when they say parallel to the x-axis, what they mean is it's going to change. It's going to get either narrower or wider, parallel to the x-axis. So I kind of want to hone in on this, and I originally made a mistake when I typed this into Desmos, and look what happened to the graph, right? So it's at 4x plus 2, and it shouldn't shift vertically. It should only shift horizontally, or stretch, as they say it. So hang on. So I fixed the formula. We're going to come over here, and notice the one that we actually stretch, the original is in green, and the one that we stretch is in purple. And it's at a stretch factor of 1/2.